The King Abdullah University of Science and Technology at Thuwal in Saudi Arabia was recently announced as one of the winners of the American Institute of Architects Top 10 Green Buildings Award for 2010. The new international graduate-level research university was established by the government-owned Aramco, the world's largest energy corporation, to drive innovation in science and technology and to support world-class research in areas such as energy and the environment. The campus project was designed by HOK Architects and was completed in September 2009. The design brief for this project was to create a work of architecture of an international rank that would be able to connect with the global scientific community and at the same time with the local Saudi culture. The challenge was to develop a project from a concept to completion in just 3 years. The most important requirement was to come up with a low energy, efficient, and highly sustainable campus. Design inspiration from traditional Middle East architecture. In order to achieve these goals and to respond to the extremely hot and humid climate of the North Red Sea, the project team, led by HOK Architects, sought inspiration from the traditional architecture of the Middle East. More specifically, they considered the following aspects. 1. The compact planning of the traditional Arab cities of the Middle East. This feature of bringing buildings closely together helped minimize the areas of the building facade exposed to the sun and encouraged passive ventilation between them. The traditional souk. Like the souk or traditional marketplace, the circulation thoroughfares within the campus are shaded and passively cooled. They are also characterized by dramatic natural lighting via their roofs and social spaces. The overhanging Arabic Bedouin tent. The project designers were inspired by the Bedouin tents to create a monumental roof system that spans across the campus building masses to block the sun from building's facade and from the pedestrian spine. Passive ventilation strategies of the traditional Arabic houses. The designers of the campus were also inspired by the design of wind towers that encourage airflow in pedestrian walkways. The wind towers used are the solar wind tower, also known as the solar chimneys. The traditional mashrabia. The mashrabia, or wooden latticework screen, inspired the design of the campus shading devices. The project designers sought to create a campus that relied less on the car and more on pedestrian and alternative transportation systems. Kaust also implements a comprehensive alternative transportation plan, which includes public and alternative forms of transportation including bicycles, segways, community-shared electric vehicles, and buses. The site also included two major sensitive marine habitats which required protection: coral reefs and mangrove forests. These two habitats were protected from the impacts of development by establishing a 50-meter buffer zone that limits development and construction activity within the coral and mangrove boundaries. The surrounding ecosystems are also protected by treating stormwater before it leaves the site and by capturing runoff, pollution, and sediment. Furthermore, to mitigate the impacts of the heat island effect, especially given the intensity of the sun and solar heat gain in Saudi Arabia, light-colored paving materials were selected to increase solar reflectivity and decrease the overall outdoor temperatures.
Passive design. The high temperatures and humidity levels of the site had tremendous effects on the project's design strategies. Therefore, sun exposure and evening solar gain mitigated using appropriate shading of the corresponding facades was taken into consideration. Also, the design sought to maximize the lighting to improve occupant comfort and to reduce lighting demand. Thus, it took the form of fingers with hollow floor plates, allowing natural daylighting to access all perimeter spaces well as a sum of the interior spaces. Moreover, the campus design encouraged natural ventilation. A pre-design analysis helped take advantage of prevailing Red Sea winds and to use wind as a cooling mechanism. The most interesting natural ventilation feature of the project is the use of two solar wind towers or solar chimneys. They induce natural ventilation during the day even in the absence of wind by absorbing solar heat using a dark surface at the top of the tower. Air circulates through the spines connected to the tower. This was achieved thanks to computational fluid dynamic studies and saved the need to condition approximately 1 million square feet. Energy conservation and generation. The design incorporated low-energy cooling techniques such as shield beams, heat recovery wheels, and displacement ventilation to reduce the cooling and ventilation loads. It also included high-efficiency lighting and renewable energy generation. The campus's roofs are covered with large solar photovoltaic arrays for electricity generation, as well as solar thermal arrays for heating domestic water. Water conservation. Water conservation is critical in Saudi Arabia, as well as in most of the Middle East. Most of potable water used in Saudi Arabia is desalinated seawater. Saudi Arabia desalinates more seawater than any other country. Implemented strategies. All gray and black water is treated and used for irrigation. Native vegetation and adaptive plants were planted on site, requiring less irrigation. Use of efficient drip irrigation systems. 40% of campus buildings employ low-flow fixtures. Operations, maintenance, and post-occupancy evaluation. For example, operations plan includes using green cleaning materials and an extensive recycling program that includes composting of all food waste. As for post-occupancy evaluation, there are plans which constantly assess the campus energy use, occupants' thermal comfort, and other mechanisms for future increase in efficiencies of all systems.